Hello, today we have the objective. I can write the equation of a perpendicular bisector of a segment, and then I can find the distance between the objects. The second one, we're going to find specifically the distance between a point and a line, and the distance between two lines. So by the end of the day, you'll be finding the distance between two lines, and we'll find the equation of a perpendicular bisector of a segment with those endpoints. Now, before we get to that, we have to remember what midpoints are. So to find the midpoint between these, we add the x's, 5 plus -1, and you divide by 2, because that's how you find the middle number between 5 and -1. Now to find the middle of -2 and 6, you add them up, and you divide by 2. So this would be 4 over 2, which is 2. This would be 4 over 2, which again is 2. So the midpoint here is the point 2, 2. Now to move forward, we need to know what the word perpendicular means. And then we need to know what the word bisector means, and then we need to put those together. Now perpendicular is when two lines cross at 90 degrees. A bisector is something that cuts an angle in half, or a line segment, or an angle in half, but in this case, line segment. So a perpendicular bisector, if we put these two things together, we're going to have a segment, we're going to have a midpoint, and then the line is going to cross at 90 degrees. So I'm going to draw a line in here. So that line is going to cross at 90 degrees, and it hits this point right in the middle. So this blue line, this purple line, is the perpendicular bisector. So if we want to draw a couple perpendicular bisectors, so for AB, I'll just find the middle. If we had a ruler, we could do it really nicely. And then it has to cross at 90 degrees. So something like that looks good. And we'll mark it by showing it's 90 degrees there. And we can say that this side is congruent to this side. So that's a good way to show that it's a perpendicular bisector. On CD, again, we find the middle. We have a line that goes through the middle. That looks like it's 90 degrees, so I'll move that over so it goes through. Draw that 90 degrees, and say that side is congruent to that side. All right. Well, hopefully now you know what perpendicular bisectors are. Now let's find equations of them. Now there's a four-step process that we're going to do to make it a little bit easier. So to find the equation of the perpendicular bisector of a segment with these endpoints, the first thing we need to do is find the midpoint. So to find the midpoint, we take 12 minus 6 all over 5 minus 2. And so that slope is going to be 6/3 over 2. That's not the slope. That's actually that was step 2. Let's go back. Hopefully you're shouting at the screen that I'm being a fool. So what we want to do is find the midpoint. The midpoint is when we add these together. So 2 plus 5 over 2 and 6 plus 12 over 2. So the midpoint is 7 over 2, which is 3.5. This is 18 over 2, which is 9. All right, now we found step 2, which is finding the slope. And now to find the slope perpendicular to that, our second slope is going to be the negative reciprocal. So that would be -1/2. So now we go in and use the slope and midpoint to write the equation of line. We have the slope, we have that midpoint, so it's y equals -1/2 x minus 3.5 plus 9. So now let's think about what we did here. So if I have 2 points, and I want to find the equation of this line, the first thing we did is we found the midpoint to find a point on that line. We found the slope of our segment in part 2 in order to help us find the slope of our perpendicular. So once we have our midpoint and our slope, then we have a point and a slope, and so we can write the equation. Hopefully that makes a little sense. So now I find the equation of a perpendicular bisector of a segment. The first thing we need to do is find the midpoint. So that would be negative 1 plus 19 over 2, and negative 4 plus 16 over 2, which would be 18 over 2 is 9. This would be 12 over 2, which is 6. Now we need to find the slope of our segment. So that's going to be 16 minus a negative 4 over 19 minus a negative 1. So that's going to be 20 over 20. So that slope is going to be 1. So now when I find the perpendicular slope, I'll call that M2. The negative reciprocal will now just be negative 1. So now I have my slope of my line. I have a point on my line. So my equation is just going to be like this, plugging in my slope and my point into point-slope form. Let's try another one. Hopefully after this one everyone will feel comfortable. Find the equation of a perpendicular bisector of a segment that has 3, 7, and 1, 4. So we start off, I didn't really need to draw that, I guess. We're finding the midpoint. So the midpoint is 3 plus negative 1 over 2, and 7 plus 4 over 2. So this would be 2 over 2, which is 1, 11 over 2, which is 5.5. Now if we want to find the slope, that's going to just be 4 minus 7 over negative 1 minus 3. That's going to be negative 3 over negative 4. So our slope is just going to be 3/4. Now our perpendicular slope is the negative reciprocal. So that's going to be negative 4/3. Now we have our point and our slope. So I say y equals negative 4/3, x minus 1 plus 5.5. And I have the equation of my perpendicular bisector. Last, we're going to look for the distance between objects. The distance between objects is the distance on the shortest perpendicular line between them. For instance, if I have this situation where I want to find the distance between this line and our point, if I could find this distance or that distance, but the shortest distance is going to be along this perpendicular. So now we have to figure out how we can do this. So you find any 2 points on this line. So I'll find this point and say this point. This one is going over 3 and down 2. So this slope is negative 2/3. The perpendicular will have a slope of the negative reciprocal, which is 3/2. So we go down 3 over 2. And you can see that lands on the line. So to find the distance, the shortest distance from the point to this line, we have to use Pythagorean theorem to find this hypotenuse. So it's 2 squared plus 3 squared is equal to c squared, or 4 plus 9 is 13. The square root of 13 is going to be our answer. So I'll just take out a calculator, do the square root of 13, and I get 3.6 for an answer. All right, let's try another one. We have this point. It can go anywhere along here, but the shortest distance will be something like that. So if we find any 2 points, let's take this point and that point. Looks like we go up 1 over 4. So if the slope of this one is 1/4, this is going to be a slope of negative 4 over 1. So negative 4 over 1, we go down 4 over 1 to get from the line to our point. So now we just use Pythagorean theorem. 4 squared plus 1 squared is equal to c squared, or that's 16 plus 1 is 17. And now we take the square root of 17. to get us to 4.12. Let's say 4.1. So now the distance between the point and the line was 4.1. Now we have distances between parallel lines. So we're going to do the same thing. We're going to find 2 points. That's one. And there's another. Looks like I went up 1 to the right. 1, 2, 3, 4. So this has a slope of 1/4. Since this is a parallel line, it'll have the same slope. So the perpendicular slope is going to be -4. So you take any point, let's take this point, go down 4, 1, 2, 3, 4, over 1. That doesn't hit the line, so we have to go again, 1, 2, 3, 4, over 1. And this line connecting them is going to be the shortest distance. So now we have to draw out our right triangle. We went down 8 and over 2. So if we have 8 squared plus 2 squared, that's 64 plus 4, which is 68. If I square root 68, I'll get the distance between them, which is 8.25. So C is 8.25 units long. All right, we have one more of these. Hopefully they're starting to make sense to you. First thing we have to do is find the slopes. So you find any 2 points. This looks like it's going through there, and you go up there. So it looks like you're going up 2 over 1. So these two both have a slope of 2. So to get from here to here, we have to use the perpendicular slope, which is -1/2. So I take any point, go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, just like that. And it will look right like that. So we need to figure out that distance. Looks like we went down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. Now to find that distance, we just do 4 squared plus 8 squared equals C squared, or 16 plus 64. When I add those, I get 80, square root 80, and that's going to be really close to 9, 8.94 is the distance between those two lines. All right, now hopefully you are ready for the homework.